Hello again, CSI 135, Introduction to Linux Students. Just wanted to post the solution set for lab number 4, and that was a lab that was due Sunday night at midnight. Alright, so let me clear my screen here. So as you can see, if I type in mail, once I've gotten logged in, inbox, and you can see that lab number 4 is right here, right? So it's message number 12. Again, the greater than sign indicates the message that's the current message, and if I were to hit the enter key, it would display message number 1. So since we want message number 12, I can simply type in 12 and hit enter. Right? So now it'll display it for me in the More editor. So I'm hitting return. So it says hello and welcome to lab number 4. It's going to ask you to perform a series of tasks using the Linux operating system, vader.aacc.edu. And just like last time, any questions that request a response should have their answers maintained in a file that you create using the VI editor. So here, it doesn't request that you name the file anything in particular. You just simply have to keep a file that will keep track of any answers that you're asked for during this quiz. And so I actually have the quiz displayed in another window. So let me swing through here. You'll notice number 16 is blank. There was going to be a file created as part of number 16 which you would append to the lab answers that you create, but we're going to go ahead and skip that. So there's only 15 questions that are asked of you here. So let me quit. Alright, so question number 1 says, in your home directory, create a directory with the name of Spring 2013, and that's all caps. So I can type in pwd to find out what my current directory is, and let's say that I was in the temp directory and I wanted to get to my home directory. Again, you simply type cd and enter with no arguments, and that will put you back in your home directory. You could also type in cd tilde, but again, the tilde is unnecessary because cd by itself will get you into your home directory, but the tilde does represent your home directory, the absolute path name to your home directory. Okay, so in order to make a directory, the command is make dir, and it wants the name to be Spring 2013 in all caps, right? So there we go. So now if I type ls space dash capital F, it will show a greater than sign, and you notice that secure CRT, it actually puts the directories in bold, right? But it also puts compressed files in bold, right? As well as compiled executables. So use the dash capital F and it'll put a / at the end of the name if and only if it's a directory. Another way that we learned was if you type ls space dash L, and you can see the first bit, if it's a D, indicates it's a directory. And so you can see here, there's the Spring 2013 directory, and the default permission set is 755. Remembering that the first 3 bits, read, write, execute, are for the owner of the file. The next 3 bits, read, write, execute, are for the group, and the last 3 bits are for everyone else. And so the owner of this file is CSI 135B25. The group to which this student belongs is, in fact, student. So users in the student group can cd into the directory and list out the contents, but they cannot change anything in the directory. They can't add files and they cannot delete files. They can't make any modifications. And those same permission sets are in effect for the user other, which is everyone else. So if you're not the owner, CSI 135B25, and you're not in the student group, the final 3 bits of the permission set apply to you. Okay, so we've created the directory Spring 2013. Now it says change the permissions on the directory you created in step 1 to 755 if they are not already set to that value. In fact, this question is to try to get you to realize that by default, your permission settings for directories that you create will be 755. Question number 3. In the directory you created in step number 1, create the following subdirectories. And it wants you to create 6 subdirectories: labs, homework, tests, notes, quizzes, and foo. So I'm going to cd into Spring 2013. Again, you'll notice I hit the capital S, and then as soon as I hit the tab key, it will auto-complete the name of the directory because there's nothing else in the directory that begins with a capital S. I hit enter, and I'll type ls minus LA, and as you would expect, the only thing present in the directory are the two ubiquitous entries, which are dot and dot dot. And again, the dot represents the current working directory, so the directory that I'm currently in, and the dot dot represents the parent directory, which is the directory immediately above the directory that I'm currently in. So if I type pwd, you can see that I'm in spring 2013, so the parent directory would be B25. Okay, it wants me to create a number of subdirectories, the first being labs, the next being homework, the next being tests, the next being notes, and then quizzes, and then foo. Alright, so now I've created those 6 directories, and as you can see, you simply use the make dir command. So question number 3 is stressing the utilization of the make dir command to create directories for yourself. Question number 4, make sure that each of the directories above has the following permission values. So let's take a look and see, are the default values 755? And again, you can see here, yes, they are. And we can tell that again by looking at the permission sets, and they're all identical. So the owner is read, write, execute, that's 7. The group is read and execute, that's 5. And everybody else is read and execute, and that's 5. So the permission set, the mode, is 755. So question number 1 says, change the permission set on labs to 755. Again, we don't need to do that because it's already 755. 4b says, change the permissions on homework to 700. So here is where we would utilize the chmod command. So I type in chmod 700 and homework and hit enter. So now when I type in ls-l, you can see the permission set on homework is now different than the other 5 directories. So the owner has read, write, and execute, which is 7. And then 00 is that none of the following permission bits are turned on for either the group student or anyone who's not the owner and not in the student group. 4c says change the permissions on the directory tests to 754. Again, you would type in chmod space 754. I type T, which is unique, and capital T, which is unique, and hit the tab key. And now I have changed the permissions to 754. So if I type ls-l and we take a look at tests, let me highlight it here, you can see that the owner is 7, read, write, and execute. The group student still has 5, a mode of 5, which is read and execute. But now when we look at other, it's set to 4. So read with no write and no execute privileges. So the ls command would work to list out the contents of the test directory, but if you're not the owner and you're not in the student group, you will be unable to cd or change directories into the test directory. Okay, 4d, again, trying to make sure that you understand that the default permission set is 755, asks you to change the permissions on notes to 755. But as you can see, notes is already 755. Alright, 4e says change the permission on quizzes to 700. So again, chmod 700 quizzes. ls-l will indicate that quizzes has been changed. And if you remember, we changed homework to 700, and so homework and quizzes share the same permission settings, and they look identical in terms of permission sets. Finally, F for foo asks you to change the permission set on foo to 751. And let's see what that looks like. All right, and here is foo, and you can see that the owner has full permissions. Read, write, execute, that's 7. The group student has read and execute, that's 5. And then everyone else, and so what that means is anyone who's not the owner and not in the student group, the final 3 permission bits apply to those users, so they would be able to CD into the directory because the execute bit is set, but the read bit is not set. And what that means is once they CD into the foo directory, they would be unable to list out the contents. All right, let's move on to number 5. So number 5 says, for this step, you will need to tar up the contents of the directory you created in lab number 3, located in the temp directory. So for the user CSI135B25, and this is an example, I would CD into the /temp/CSI135B25 underscore 02062013 directory. And so here's the directory that I created in lab number 3. And let's get a long listing here. So we had a number of directories that were created, and there is a tar file in here. So I'm going to go ahead and I'm going to remove that tar file first. Okay, so the hint says make sure you are in the directory when you run the tar command. The name of the file must be, and let's create that right now, so tar cvf, so it's create verbose file, and the name of the file will be CSI135B25 underscore tar file underscore 0213 2013, and we'll end it with a .tar because we want to make sure that we understand that this is a tar file, and then when we look at it we can recognize it right away. So again, I want to tar the current working directory, so I simply then need a period at the end. Okay, so you'll notice that since I'm in the directory, as soon as I begin the tar process, it creates that tar file, but it says file is the archive, not dumped. And what that means is that file which I'm creating, which is the tar file, does not become part of the archive because it is the archive. It is the tar archive file. So now let's do an ls-la, make sure we see everything here. And as you can see, here is my tar file. And the default permission sets, it's 644. Right? Okay. So that was question number 5. Question number 6 says copy the tar file you created in step number 5 to the directory you created in step 3F. So if you roll back and look at 3F, you'll notice that the file was foo. Now, there are a number of ways that we can get that file, get a copy of that file into the foo directory. So the first I want to demonstrate is using the absolute path name. So I could type in copy space. If I type, I can even get away with just a lowercase c because it's unique at that point. Hit the tab key for the autocomplete feature, and now I'm going to provide the absolute path name to the student directory. So it's /u/students/spring is it spring 13? Let's see what we've got here. Alright, so I hit tab twice to list that out. So it's spring 13 CSI135/B25. It's a long path name, sometimes difficult to remember. So we're copying the tar file using the absolute path name into the directory foo. And let's make sure of that. And yes, that's what we want. Whoops, hit the key by accident. So B25, and then spring 13, and then foo. Alright, so I hit enter, and let's go back and take a look at this again. So there's the command there. So it's copy CSI135B25 with the tar file name, and then I use the absolute path name, right, and then hit enter. And it copies the file into the foo directory. So to check, I could type in ls space, and if I use bang exclamation mark, the bang exclamation mark combination in the bash shell, and this is one of my favorite features of the bash shell, the bang exclamation mark will take the last argument from the previous command and substitute that value if you use bang $. So when I type ls space bang $, it grabs the last argument, which is the absolute path name to the foo directory, and substitutes it. And then it gives you an output here and shows you what that command would have looked like after the substitution. So again, bang $, one of my favorite features. So we do ls u/u/student/spring13, so forth and so on, down to foo. And there's a copy of my tar file. So what's another way I could have copied this file into the foo directory? And if you're thinking about the tilde, you're spot on. So I could have used, oops, let's back up over that, tilde /spring13/foo, and you don't necessarily need that following slash at the very end. It'll when you use the tab key, it'll put it in there automatically because it's anticipating that you're going to be providing either another name of a file or a directory. So again, instead of having to type out /u, or like you saw previously here, I had to hit tab to figure out the path down to the B25 directory, I can just simply use the tilde /spring2013/foo. I hit enter, and that would have also successfully copied the file in. Another way I could have copied that file would have been to cd into my home directory, and then go into the Spring directory, and then go into foo. And now I'm here, and let me go ahead and remove this file. So you can see there are no files currently located in the foo directory. So if I were to type copy /temp/csi135b25, so now we're approaching this copy from an alternative point of view. Initially, we were in the directory with the tar file, so we can get away with just giving the tar file name because it was relative to where we were at. Now that I'm in the foo directory and the tar file is not, the tar file is down in the temp directory, I'm going to have to put in 2013, CSI13502, pretty sure it was 13. Let me double check on that. Yeah, 06, I apologize. There we go. And then the name of the tar file, which is CSI135b25. Now, this is where you could take advantage of the dot, right? Because what I'm saying is, create a copy of this file, the first argument, right, which is the absolute path name down to the tar file, and the dot says the current working directory. Well, we know that I'm in the foo directory, and that is my current working directory. So by simply placing the dot there, it will automatically put a copy of that tar file with the same name right in the foo directory. Okay? So let's say that you wanted to pull that file in and give it a different name, right? I don't want to name it CSI135, so let me delete that. We'll get rid of that tar file. As you can see, it's not here in the foo directory, pwd, print working directory. I'm in the foo directory, so I'm going to run the copy command again. I'm using the up arrow right there, right? The up arrow to get me back here. So if I want to rename the file, I would put /, so current working directory, and then the separator between directories and file names is the /. I could put in my new tar file, .tar, right? And then hit enter. Now when I type ls-la, the tar file is still there. Let's take a look and see if I do a tar tvf, which is for an inventory, right? It's going to show me the tar file, but it's not going to unpack it. It's just going to give me a listing of what is actually in this tar file. And so I want to make sure, hey, is this file still a valid file? And sure enough it is, because there are the contents of the tar file, all the directories and the files that we created as part of lab number 3. Okay, so that was step number 6. Move the tar file that you created in step number 5 into the directory that we created in step number 3. Now, let me clear this out here, and I'm going to remove my tar file, and I'm going to run the copy command that brings it in with the same name so that we're all working with the same set of assumptions. So ls-l So there's my tar file. Step number 7 says, using the Gzip utility, compress the tar file you now have that is located in the directory you created in step 3F. So I could simply do Gzip space, and I like the -v because I like to see what kind of savings I'm going to achieve by using Gzip. And I'll hit enter. And the Gzip command, very conveniently with that -v, tells me how long it took and how much was saved. And take a look at that. 95.60% saved, right? So initially this file was 20,480 bytes. Let's take a look and see what the size of that file is now. All right. You can see that it shrunk it from 20,480 bytes all the way down to 901 bytes. Now, let's compare that to the Gzip utility, because as you read in the textbook, the Gzip compression algorithm is more efficient than the Gzip compression algorithm. So let's put that to the test. So I'll type Gzip, -d, and then we'll do CSI 135. And so again, that -d stands for decompress. So now we're back to just our tar file. So let's see, is the tar file still intact? Because I want to make sure, I want to make sure that compressing it with the Gzip utility didn't damage the file or didn't corrupt the file at all. So let's check, just to make sure. And yep, everything is still inside that tar file. Okay, so now I'm going to use the Gzip utility, and Gzip used to be one of my all-time favorite utilities, and it also takes the -v option, which provides verbose output, and so we'll Gzip the file CSI 135 B25 tar. Okay, so as you can see, we saved 95.7%. So I'll scroll back up here just a bit. So here we only saved 95.60%. Down here we saved 95.7%. So let's take a look. Let's see what it looks like right now. And as you can see, it's 935 bytes in size. And as I scroll back up, and we got to take a look at it after it was Gzipped, here it's 901. So interestingly, it saved more space, right? 95.6 as opposed to 95.7, but the Gzip utility actually leaves you with a larger file. So very interesting, right? And again, you could argue that, hey, we're splitting hairs here. We're talking about 30 bytes, or to be more specific, we're talking about 34 bytes in size. And again, the point isn't to argue that one's better than the other. It's just simply to show you that the algorithms that are being used are different, and you're going to receive different results when you're using Gzip as compared to Gzip. Okay, fantastic. So Gzip -d, and I'll even do the -dv, and you get verbose output when you decompress. And so again, let's do an ls-l. That's my only file, tar tvf on CSI 135, and let's check and see, is everything still okay in this file? Here we go, nothing's been damaged, we're good. Excuse me. So now I'm going to go ahead and bring the Gzip command back up, and we're going to scroll back with the arrow key, and I'll change it to -v, right? Oops, sorry, gotta get rid of this. That's what we're creating. So there we go, 95.6% saved again. ls-la, and there's the file, Gzipped. Okay, that was number 7. Number 8, make the permissions on the .tar.bz file such that you, the owner, has full permissions. Users who are members of the student group only have read permission, and all other system users have no permissions at all. So let's attack it one permission set at a time. So the owner, right? Number 8 says has full permissions. So that's going to be 7. Read, write, and execute. For the group, it asks that they only have read permissions. So the R value is 4 because there is no write, which is valued at 2, and there is no execute, which is valued at 1. And then you have others, and it says no permissions for the others. And so that's easy. That's going to be 0. I type in C, and I strike the tab key. And when I strike the tab key, it auto-completes the file name for me. And as I hit enter, Now if I type in ls-l, you can see the owner has full permissions. Users in the student group have only read with no write and no execute, and anybody else, and again, the last 3 bits are for any user who is not the owner of the file, who is not a member of the student group. Those last 3 bits apply to those individuals. And so you can see here they have no permissions whatsoever. Okay, so that was number 8. Number 9 asks, what does the dot represent inside of a directory? And again, that represents the current working directory. Number 10 says, what does the directory ... represent? And we had already looked at that. The ... represents the directory immediately above the current directory that you're in, and that is the parent directory. All right, so number 11 gives you an example of a command, and it says you have just run the following command, and it's make dir /temp /stuff /junk kjds. Okay, so I've just run this command, and it comes back, and I'm going to change the name a little bit here, and it comes back and it says cannot create directory, and it gives you the name of the directory you're trying to create. It says no such file or directory. So question 11 asks you, given that the temp directory exists, and we know that, right? We can cd into /temp, and there are files in here. It says given that temp exists, but that the directory stuff does not provide the single command that could be used, and given that you're in your home directory when you run it, so let's type cd to get into our home directory, right? And there we are. Give the command that would successfully create the desired directories. So it wants a single command. So what that means is it's not looking for /temp /stuff, right? And I think I created that as an example. So let me go ahead and get rid of /temp /stuff. Ah, somebody else owns it. Okay. So what we're going to do then is I'll use stuff1. So if I were to do make dir /temp /stuff1, right, this isn't what the question's asking for. It doesn't want you to make this directory and then to make the junk directory and then to make the next subdirectory. So it's looking for everything on one command. So make dir, and again from the reading, the -p command will allow you to do temp stuff, and I'll do 99 to make sure that it's not there, junk, and then kjds, and we'll stick with just that. So again, the purpose of question 11 is to get you to realize that the -p option to the make dir command, and let's take a look at the man page, is to get you to understand that if the parent directories don't exist to the directories that you're trying to create, that -p will create those for you. And again, it says no error if existing, make parent directories as needed. So temp existed, right? So that's why we did not get an error. And then it said make the parent directories as needed, so it made stuff99, and it also created junk, and then it allowed us to create the final subdirectory, kjds. So now if I type in ls/temp /stuff99 /junk, you can see that there's the directory kjds. And that was number 11. All right. What is the default numeric access permission setting on new files you create? And again, we kind of looked at this. So if I were to type in touch new file and hit enter, and then type ls-la on new file, the default permission setting is 644, right? So the answer to that is 644. It says, what is the default numeric access permission? This is number 13. What is the default numeric access permission setting on new directories that you create? So we could go back and look at temp junk99, but let's create a new directory here called make dir dir, right? So if I type ls-l for the long listing, and remember the -l is going to give us the permission settings, you can see it's a directory, read, write, and execute. The sum is 7 for 4 plus 2 plus 1, and then 5, and then 5. So the answer is 755. Number 14 says, in the following directory there are 2 files. What are the inode numbers of the files? And what does this tell you about the two files? So let's go into /temp /CSI135B, and I think put some B's in there, BBB, /files, right? So if I type ls-la, let's start with that. There's two files in here, .junk and .symbolic junk. So, and this is kind of a, don't want to say a trick question, but one to get you to think. So initially you may be thinking, hey, this is a symbolic link, but it's not, because you don't have the L and then 777 set as the permission set. So if I do a man on ls to see what option is available that will show me the inode numbers. And you see right here, -i. So with -l, print the index number of each file. And it says with -l. So let's do ls-i, and this does work by itself. Nope, -i, and with hidden files we'll need that -a. So again, it'll show you the inode numbers here, but again, this is a little jumbled together. If you had a lot of files in here, this would be difficult to read. So you don't have to use it with the -l, but it certainly makes it easier to read. So let's take a look. .junk and .symbolic junk, and here's the inode number, and the inode numbers are the same, right? So both of these files have the same inode number. In addition, they're the only two files in here, and they also both have two links. So when you put together the fact that the inode number is the same and the link count is also the same, what this is going to indicate is that these are hard links, right? That, I shouldn't say they're both hard links, but one is the regular file and the other has been created as a hard link to that file. Okay, the final question, number 15. Why would I receive the following error message? So if I'm in my home directory, and let's clear this out, type cd and then pwd, and I type, let's make sure I have a file here. So I have a file called junk, right? And I'm going to create a hard link to the file junk, and I'm going to put the hard link in temp, and I'm going to call it new_junk99, right? And I hit enter. And I receive this error message. It says ln: creating hard link temp new junk99 to junk. It says invalid cross-device link. So what does that mean? Invalid cross-device link. What that means is, and I'll type df space -k, and this is going to print out the partition table for the file systems on the class system vader.aacc.edu. So invalid cross-device link means I'm in my home directory, which is /u/students, and then the rest of the path, Spring 13, CSI135. But this is its own unique partition. Okay? I'm in my home directory, so I'm in a directory on this partition here. I'm trying to create the link, the hard link, to a directory that's located under this partition, the root partition, right? So invalid cross-device link indicates that you cannot create a hard link across partition boundaries. So if I try to create a hard link from the /var directory into /u/students, it would also fail. And again, the reason for this is that when the file systems are created initially and your system is built, each file system is allocated a unique set of inode numbers. And so when I'm creating files in the /u/students partition in my home directory, the inode numbers that I'm being allocated, there's no guarantee that those inode numbers are going to be available under another partition, because there are other activities taking place on that partition, and those inode numbers may have already been given out. Okay, so what you would want to do at this point is email your lab number 4 answers to me. And so let's say that I put all my answers in, well, let's rename junk, and we'll call junk lab number 4. So I would type in mail space -s, and the -s says what follows will be my subject. And again, if and only if there are going to be spaces in the subject line, so this space is my lab number 4 response, do I put it inside the double quotes? If I simply gave the subject line as just Lab 4 with no spaces, I would not need to enclose it within double quotes. And you're sending it to TPB. Again, you do not need to use vader.aacc.edu because we are on the same system, but you could if you wanted to. There's nothing wrong with that. Again, how do I read a file in? ~r space lab number 4, and you're going to receive confirmation. You've got 28 lines have been added, 999 bytes, so in this case it's 999 characters probably, and then a period by itself. And again, you want to make sure that you CC yourself here, right, so that you can see what you've sent me, okay? And then you hit enter. So if I were to type in mail all by itself to see what kind of mail I've got, there it is. I've got my Lab 4 response. I hit enter, and it just so happened that it was the hosts file. Oops. So Control U will pull back that whole line. I could have done Control and delete. And then I'll quit out, and it says saved one message to inbox. So if I type mail now, I have no mail. Remember that in the home directory there is a file called inbox, and you can see I've got quite a bit of email in here. And the permission set on inbox while we're here is 600, because you don't want other students in the group or anyone else to read what you have in your inbox. And to look at the inbox, again, it's mail space -f inbox. All right, and there we go. So that is the video tutorial for the solution set for lab number 4. I hope you found this useful, and I will see you all on Wednesday night. Enjoy the long weekend and have a great Saturday.